The art of war has been turned on its head in recent years. New technologies like AI, drone swarms, underwater drones, and electronic warfare have upended the status quo, introducing capabilities and threats considered science fiction just a few decades ago. For the world's militaries, it's a question of adapt or die, and Sweden has adapted faster than most. It's been on a serious roll of late. In the past couple of years, the Swedes have developed their own drone swarms, become one of the first nations to integrate AI into their JAS-39 Gripen E fighter jets, and pioneered a new modular approach to anti-drone systems with Loki, to name but a few. Now, Sweden is about to change the rules of the game again, this time under the waves. So, get ready for the world's first fifth-generation submarine, the Blekinge-class or A26. This innovative submarine packs a host of features that make it ideally suited for next-generation warfare in the Baltic Sea and beyond, and Russia at this point appears to be powerless to stop it. Here's everything you need to know about the A26 and how it could dramatically shift the balance of the power in the Arctic theater and beyond. It should come as no surprise to learn that the company behind the A26 is Swedish giant Saab, with a product range including the aforementioned Loki and Gripen E, Global Eye airborne early warning and control aircraft, Carl Gustaf M4 recoilless rifle, and the NLAW anti-tank missile. Saab's ability to consistently deliver world-class weapon systems across domains is beyond dispute. The company's previous forays into submarines weren't too shabby either. Its Gotland-class or A-19 submarines may have been made in the 1990s, but upgraded models proved their mettle in 2005, sinking the US aircraft carrier USS Ronald Reagan repeatedly during exercises, without the carrier even being aware it was there. And further upgrades along the way mean they're still regarded as some of the finest diesel-electric submarines under the waves. To be precise, Sweden's three Gotland-class submarines, the HSWMS's Gotland, Uppland, and Harland, weren't actually designed by Saab itself. They were originally designed and built by Kockums AB in Malmö, an independent company at the time. Saab acquired Kockums in 2014 and renamed the shipyard Saab Kockums. Since then, Saab has been responsible for the submarines' service, maintenance, and major upgrades, including a comprehensive midlife upgrade program for all three vessels carried out from the late 2010s into the 2020s. So, what does that have to do with the new A26? Well, the recently upgraded A19s reportedly received many of the new systems that appear in the A26. More importantly, the reason that Saab acquired Kockums in the first place was primarily due to the A26 program. Kockums had begun concept development for the new A26 in the mid-2000s as part of Sweden's broader effort to modernize its submarine fleet. But then, in 2014, FMV cancelled the program, and for good reason. You see, Kockums had long been under German ownership, having been incorporated in Hufvagtswerke Deutsche Werft in 1999 and later into ThyssenKrupp Marine Systems or TKMS. Sweden's primary submarine producer was now technically a German-controlled company. The Swedish government, understandably, had major issues with a key national security asset like its primary submarine producer falling under foreign ownership. The situation escalated, culminating in the cancellation of the contract. Development came to a standstill, with a partially completed multi-million kroner hull left stranded in mid-air, so to speak. To break the impasse, Saab AB acquired TKMS AB from ThyssenKrupp in 2014, renamed it Saab Kockums, and regained control of the Karlskrona shipyard and its workforce of around 900 employees. With national security concerns eliminated to the government's satisfaction, the wheels of the project quickly started turning again. In June 2015, FMV awarded Saab Kockums a new contract for two A26s, valued at 7.6 billion Swedish krona, around $820 million. The project was back on track and full steam ahead. The keel of the first A26, designated HSWMS Blekinge, was laid at the Karlskrona shipyards in late June 2022, with the second submarine, HSWMS Skåne, following in parallel production. As a result, a massive, incredibly complex construction effort is currently underway. The A26 is being built in 5 sections and has 140 systems on board, which we'll discuss in detail shortly. Those systems require a whopping 600,000 individual parts, 62 miles of cable, and 10,000 unique pipes and conduits. Saab has employed cutting-edge engineering processes to implement this immense process, including model-based definition, digital twins, threads, and product lifecycle management tools. Even so, the ownership controversy, supply chain disruptions like the COVID-19 lockdowns, and the sheer size of the supply chain have taken their toll. As per the most recent procurement contract award in October 2025, delivery of the two vessels have been delayed again. The ships were originally expected to be ready for service in 2024 and 2025, but are now only expected in 2027 and 2028. The total cost has also almost doubled, from around $1.51 billion to $2.7 billion. Now, this kind of production and budgetary overrun is all too common and usually unwelcome. Delayed deliveries compromise deployment strategy and timetables, and large cost overruns are never an easy sell politically. But in the case of the A26, the delay has in many ways been a blessing in disguise. The technology of war has changed at such an eye-watering pace over the past few years that military producers around the world are scrambling to keep up. Systems planned for integration into ships and aircraft can become obsolete before they've even been installed. That means either scrapping the project and swallowing the sunk costs, or a redesign, meaning further delays and cost overruns. If the A26 had been delivered according to the original schedule, some of its most compelling features may not have been on the table. Now, Saab has the opportunity to integrate cutting-edge, future-proof features right out of the starting blocks. And the A26 is jam-packed with exactly those kinds of features. Features that make it a potentially unstoppable force and should keep it that way for the foreseeable future. A fifth-generation submarine in every sense of the term. But what is a fifth-generation submarine anyway? And what makes the A26 the world's first? A fifth-generation submarine is defined primarily by its capability to seamlessly integrate into NATO's multi-domain operations, or MDO, framework, moving beyond traditional underwater warfare to operate effectively across sea, air, and information domains. Previous submarine generations focused solely on underwater stealth and firepower. Fifth-generation submarines are much more versatile, emphasizing balanced multi-domain signatures, advanced AI for rapid data processing, and seabed warfare capabilities, including the deployment of unmanned underwater vehicles or UUVs and special forces. As we'll see shortly, the A26 possesses all of these capabilities in spades, and is long on stealth and firepower to boot. Now, fifth-generation submarine design also emphasizes modularity. Modular payload bays allow rapid reconfiguration for different roles, including intelligence, surveillance, reconnaissance or ISR, strike and special operations roles. Need to switch from a surveillance mission to a mine-laying operation? Detach the mine-laying module and insert the mine layer in its place. And the A26's hull is being built with modularity at its core. As noted earlier, 5 separate sections are being built simultaneously, with the stern cone section alone weighing about 80 tons. When they're all ready, they'll be clicked together into a whole like gigantic Lego pieces. This modular construction means the A26 can be rapidly reconfigured for diverse roles, such as integrating unmanned underwater vehicle or UUV, launch and recovery systems via dedicated multi-mission portals. A modular design also bolsters the export potential of the vessel, allowing the manufacturer to add or remove features to meet the requirements of diverse navies. It also allows a nation to hold back technology that may represent national security risks, a prudent move on Sweden's part given the history of A26. Be that as it may, as you can see, the A26 ticks all the fifth-generation submarine boxes confidently, and it's the first submarine to do so. It combines stealth, endurance, and modular flexibility in ways that challenge traditional assumptions about diesel-electric platforms and terrified the Russians. Its design provides a striking example of how advanced conventional submarines can provide highly capable, lower-cost alternatives to nuclear-powered vessels, offering operational flexibility across multiple theaters and mission scenarios for a fraction of the cost. Designed as a multi-domain system, the A26 can conduct intelligence collection, deploy unmanned systems, support special operations, and monitor undersea infrastructure, all while remaining submerged and incredibly difficult to detect for extended periods. Indeed, the A26's defining aspect is arguably its multi-domain signature management, achieved through acoustic, magnetic, radar, electric, infrared, and visual suppression techniques. In its role within NATO's MDO framework, the A26 is equipped with electronic surveillance and communication systems that can gather, classify, and transmit data to Allied command networks effectively. Its powerful electronic support capabilities enable passive signal interception and classification to provide a widescreen picture of enemy communications, radar emissions, and movements. It's like a high-powered Hoover vacuum perched on the seabed, sucking up information about everything Russia is doing on and below the waves. Of course, being an underwater vessel, the primary signal detection is via sonar, and the A26 is far from lacking in this regard. The sonar suite integrates Atlas electronic bow and flank arrays, HF interceptor sonar arrays, Kongsberg SA9510S mine avoidance sonar, and Safran Series 30 optronic masts for periscope and surface observation. These passive and active sonar elements operate across low to mid-frequency bands, prioritizing sensitivity in the littoral environments prevalent in the Baltic Sea. Electronic support measures, or ESM systems, further augment the A26's acoustic detection by monitoring radar and communication signals, allowing the submarine to geolocate emitters and classify threats passively. As you can imagine, the submarine's vast array of active and passive detection equipment generates a large amount of data continuously that needs to be processed as quickly and slickly as possible. And Saab has harnessed the power of AI to expedite the process. According to the company, the A26's onboard AI-assisted data processing allows faster synchronization with air, land, cyber, and space assets in joint operations, contributing to what the Swedish Navy calls underwater information warfare. That includes both exploitation of enemy communication links and protection of national undersea infrastructure, particularly critical undersea cables and pipelines. Managing all of these signals and data and selecting the right responses are no easy feats, but the A26 is abundantly equipped for the task. Its 9LV Combat Management System, or CMS, provides command, control, communications, computers, and intelligence, or C41 coordination across naval platforms and mission types, increasing the speed and effectiveness of decision-making. The 9LV fuses inputs from sonar arrays, ESM, and optronic sensors to provide operators with a unified tactical picture, giving them the power to rapidly identify and respond to threats. The 9LV incorporates advanced processing for real-time data correlation from both radar ESM and communication ESM systems. That gives the A26 greater ability to detect electromagnetic emissions without actively transmitting itself, which can compromise stealth. Enjoy detailed military analyses and weapon showcases? That's what we deliver week in, week out here at the Military Show. Subscribe to the channel for the sharpest military insights on YouTube. Now, the technologies we've just discussed are game changers, particularly in the neck of the woods where the A26 is primarily intended to function, at least in service with the Swedish Navy, the Baltic Sea. The A26's streamlined hull is optimized for high-stealth operations in littoral environments, and particularly in the confined and shallow waters of the Baltic. It's a sea that poses a unique set of challenges. It ices over in the winter and has a tricky sea bottom that makes it very difficult to use sonar. It's essentially one big littoral combat zone, complete with shallow waters and complex coastlines that make it completely unsuited for nuclear submarines. But not for the A26. The A26's pressure hull utilizes advanced high-strength steel that supports structural integrity at operational depths while minimizing acoustic signatures. It's also free from external tanks, which further reduces its detectability and is reinforced for shock resistance, allowing operations in heavily mined environments like the Baltic Sea. With a length of just under 217 feet, a beam of 22.14 feet, draft of 19.68 feet, and displacement of around 1,925 tons surfaced and 2,100 tons submerged, it's perfectly suited for navigating areas with limited water depth, like much of the coastal Baltic Sea. Navigation is further enhanced by its X-rudder stern configuration, consisting of 4 independently controlled surfaces that provide superior low-speed maneuverability and stability during surfacing or in turbulent conditions. This design improves handling in archipelagic environments like the Baltic without compromising hydrodynamic efficiency. The combination of the pressure-resistant hull and X-rudder configuration also give the A26 another powerful capability, especially with regards to seabed warfare. It can rest directly on the seabed, protecting underwater cables, surveilling maritime choke points, and controlling critical sea lines of communication. What's more, the Russians probably won't have a clue that it's even there, thanks to the A26's advanced stealth features. In fact, Saab has a superbly apt name for their stealth system: Ghost, short for Genuine Holistic Stealth. Developed by Saab, this advanced stealth technology is designed to minimize a vessel's detectable signatures across acoustic, magnetic, and electromagnetic spectrums. There are multiple components to the technology, foremost among them being the A26's engine configuration. The A26 utilizes a hybrid diesel-electric and Stirling air-dependent propulsion AIP system. The diesel-electric setup includes 3 diesel engines for recharging batteries during surface transit or snorkeling. Recharging the batteries in this way means the A26 can utilize battery-powered electric propulsion for silent submerged operations at higher speeds. The AIP component comprises 3 Kockums Stirling engines. Each delivers around 75 kilowatts of mechanical power converted to electricity, giving a combined AIP output of about 225 kilowatts. And it's in this AIP component of the engine that the magic lies. Saab's patented Stirling Air-Independent Propulsion, or AIP system, allows the A26 to operate submerged for several weeks without surfacing. For a non-nuclear powered submarine, that's some feat in and of itself. Previously, that high level of endurance was reserved for nuclear-powered submarines. Diesel-electric submarines are typically limited to a few days submersion before needing to surface to take on board more oxygen for its engines. The Stirling AIP system uses stored liquid oxygen and diesel fuel to generate power through external combustion in a sealed cycle, producing minimal vibration or noise. Compared to other AIP technologies such as fuel cells, it's more cost-efficient, easier to maintain, and compatible with modular retrofitting. How it works is a prime example of that particular Swedish blend of practicality and ingenuity. The Stirling AIP's closed-cycle external combustion engine burns diesel fuel with liquid oxygen stored in onboard tanks. The combustion heats a sealed inert gas like helium inside the engine, causing it to expand and drive the pistons. The pistons then turn a generator, producing electricity to power the submarine's electric motor or charge its batteries. The heated gas is then cooled by circulating seawater before being recompressed, completing the cycle. Crucially, this entire process happens while the submarine is submerged and without needing atmospheric oxygen. This remarkable system provides 4 main advantages to the A26 and indeed the Gotland-class submarines that also use this system. The first, as we discussed, is extended submerged endurance. The Gotland class can stay submerged for up to 14 days, traveling at 5 knots without snorkeling, good for a range of 1,700 nautical miles. Modifications to the A26 mean it's expected to be able to stay submerged for even longer. Reportedly, it can stay submerged for up to 45 days, including around 18 days operating solely on AIP, with a top submerged speed of roughly 12.4 miles per hour. The second advantage is extreme stealth and quietness. The Stirling engine is almost completely silent and vibration-free because combustion is continuous and external to the working parts. The result is a very low acoustic signature, which makes the submarine exceptionally difficult to detect, especially in the shallow, cluttered waters of the Baltic Sea. The third advantage provided by the AIP is reduced detectability. Snorkeling exposes the submarine's mast and creates noise and a radar signature. By eliminating the need to snorkel, the submarine remains hidden, drastically lowering its risk of detection by radar, sonar, or visual means. Fourthly, the Stirling AIP is more cost-effective to produce and maintain compared to other AIP technologies like fuel cells or nuclear power. In effect, it offers a high-performance alternative without the complexity and expense of nuclear propulsion. To be fair, other AIP systems like fuel cells can be slightly quieter, but the Stirling engine's combination of long endurance, profound quietness, and proven reliability make it the ideal choice for the world's first 5th-generation sub. But the ghostly features of the A26 certainly don't end with its engine. The whole streamlined teardrop shape minimizes flow-induced noise and turbulence. Anechoic coatings on the outer hull absorb active sonar returns during submerged operations, and rubberized mounts and baffles encase the ship's machinery, preventing vibration transmission to the pressure hull. Combined, the result is self-noise levels among the quietest in non-nuclear submarine classes. Even when surfaced, the A26 offers significant stealth. Traditional hull penetrations increase radar cross-section and potential leak points. To avoid this issue, the A26 uses non-penetrating optronic masks equipped with electro-optical sensors for periscope and search function, which are integrated with high-resolution imaging systems. This mask configuration enables the A26 to maintain stealth during shallow water or periscope depth surveillance without exposing protrusions that are vulnerable to visual or electromagnetic detection. Perhaps more pertinently, the whole setup aligns with NATO's network-centric principles by enabling secure data links for sharing sensor-derived intelligence with allied units in the air and at sea. Of course, the A26 wasn't just built to identify threats, it was built to eliminate them too. The primary offensive armament is 4 533mm torpedo tubes, which can launch heavyweight Torped 62 or 63 torpedoes in anti-submarine and anti-surface warfare roles. The TP-62, a pump jet-propelled weapon with a range exceeding 25 miles and a 286.6-pound warhead, provides particularly versatile targeting against surface vessels and submarines. These tubes also support the deployment of naval mines for aerial denial operations. For good measure, there are also 2 400mm tubes for launching the lightweight Torped 47, also known as the Saab Lightweight Torpedo (SLWT). This layout can accommodate a weapons load of approximately 20 units in total, including torpedoes and mines. These are stored, you guessed it, in modular configurations to optimize mission-specific payloads. And it's the next module in the sequence that's probably the most exciting of the lot. Complementing the torpedo tubes is a 6.5 by 1.6 feet multi-mission portal that serves as a flexible lockout chamber. It's designed specifically to deploy UUVs or deliver up to 8 Special Forces divers with their equipment. The A26 is designed to comfortably carry a crew of up to 25, expendable to 35 including divers or other specialized forces. The multi-mission portal means that the A26 isn't just able to fire torpedoes and mines, it can deploy Marines for covert insertion or multi-purpose UUVs for seabed operations, and without compromising the submarine stealth profile. Now, the A26 isn't the only submarine in the waters that offers the ability to deploy UUVs and special forces. The US Navy Virginia-class submarine's payload module does pretty much the same thing, and the German Type 212 and 214, along with the Japanese Soryu-class, are both technically capable of carrying out specialized payload like UUVs or divers. But unlike these subs, the A26's multi-mission portal is a central, configurable design element rather than an add-on capability, and it's the first submarine to include this 5th-generation capability. The modular hull architecture also supports future integration of vertical launch systems for cruise missiles, with proposals including up to 18 cells for land attack or anti-ship munitions like adapted Tomahawk variants. This module allows the A26 to scale for hypersonic or extended range threats as technology evolves. All things considered, it's easy to see why the A26 is considered the next generation in submarine technology. More pressingly, the combination of stealth, extended submersion, range of mission profiles, and modular extendability are set to change the game in the Baltic Sea in ways Russian President Vladimir Putin can't be enjoying too much. He now has a formidable new asymmetric threat to Russia's already creaking naval operations to contend with. For starters, he's going to struggle to locate the A26. The Baltic's shallow, brackish water and complex acoustics create blind spots that favor small, ultra-quiet diesel-electric submarines like the A26. The ship's ghost technology couldn't be better suited to exploit this environment, allowing the sub to disappear from Russian detection at short ranges. And if you can't find it, you can't hit it. The A26's Stirling AIP engine means it can find a nook on the seabed and park there for days on end, practically unfindable, a constant hidden threat. Putin might know it's out there somewhere, but he won't know where it is, what it's doing, or how long it'll be there doing it. Worst of all, this is not just an isolated Swedish problem for Putin, it's a NATO problem. The A26 can lie on the seabed, silently waiting for the right moment to launch TP-62s at unsuspecting Russian frigates and corvettes on the surface. It can deploy divers or UUVs to sabotage critical Russian undersea pipelines and communication cables right under their noses. Or it can just lie there like a silent sentinel, mopping up data about Russian movements and feeding it back to NATO without the Russians being any the wiser. Indeed, even a small number of A26 acts as a powerful deterrent against any Russian aggression, due to the disproportionate damage the element of surprise allows them to inflict on the Russian fleet. So, Putin is likely going to have to divert significant resources to anti-submarine measures in the Baltic to counter the A26 as best he can. That's a major unwanted headache for a nation whose military and budget is already stretched thin in Ukraine, particularly in such difficult waters as the Baltic. Scant comfort for the poor autocrat, but at least he has a few years before the nightmare manifests into reality. Although at its current rapid rate of evolution, who knows what fearsome new capabilities the A26's modular design will have integrated by then. We'll of course be watching closely and keep you updated, so stay tuned, and in the meantime check out this video about that other marvel of modern Swedish modular military engineering, the Loki anti-drone system mentioned earlier. Thanks for watching.